A question I've seen asked fairly often is how to calibrate for a specific filament in order to get the best possible print quality. The answer to this is somewhat complicated, and in my opinion beyond the scope of a single video due to the range of parameters you'll need to tune. However, broken down into smaller bite-sized ones, it becomes much easier to understand and follow along with. Last month we covered calibrating pressure advance through OrcaSlicer's built-in tools, and today we're going to cover dialing in flow. As for the order of operations, this is a bit backwards, and I recommend calibrating flow before pressure advance. In this video, I'll show you how I tune flow for any new filament as we go step by step through the process. By following these steps, you'll have super smooth and consistent top layers. So, with all that being said and without further ado, let's get right into today's video. Thank you to VOXELPLA for sponsoring today's video. VOXELPLA aims to make 3D printing more accessible with a reliable and affordable filament. This filament is used exclusively in a 150 machine print farm. Their PLA Plus is now available in 12 great colors, with my favorite being Fire Truck Red and Lavender Purple. VOXELPLA performance is excellent, even on high-speed printers. Pricing is $16.99 per kilogram, and at 3 spools, shipping is free within the US. Bulk discounts are also available. VOXELPLA has also expanded to offer printer upgrades like the Vision enclosure for the Bambu Lab P1P or the Bento Box filter. This 2-stage filter is compatible with Bambu Lab printers and even the Voron Trident. It includes everything needed, and setup is super quick, so you can get back to printing right away. Links will be in the description to voxelpla.com, so you can find out more about their high-quality, affordable filaments and printer upgrades. Before we do anything else, we need to first make sure that our extruder is properly calibrated. One of the most popular videos on this channel is on how to calibrate your extruder motor's E-steps. The purpose of this is to ensure that when your G-code is requesting a certain amount of filament, that the printer is extruding that length. This should be tuned on a retail printer for its default hardware, but any upgrades or swaps to the extruder will require tuning this again. While my previous video calibrated E-steps, which is needed for Marlin firmware, Klipper uses rotation distance instead. Klipper's documentation describes this as the amount of distance the axis moves with one full revolution of the stepper motor. If you know your steps per millimeters, there is a simple formula to convert it to the rotation distance. The good news is that the process of calibrating the rotation distance is actually very similar to calibrating E-steps, with the exception of the formula used. In my case, I'm calibrating a Voron Trident using the Clockwork 2 extruder. Just about any printer config I've used comes with a default recommended rotation distance for the extruder. Even for extruder upgrades, this value will often be provided by the manufacturer. You can find the rotation distance under the extruder section of your printer.cfg file. We can see here that this is set to 21.525. To calibrate the extruder's rotation distance, any filament can be used. However, I like to use a lighter colored PLA so I can extrude at lower temps and easily see the mark that we will be placing on the material. Since the Trident uses a direct drive extruder, I'll remove the reverse Bowden and feed the filament directly into the toolhead. Reverse Bowdens will have a fairly large inner diameter compared to the 1.75mm filament that we're using. This allows for slack, which is fine for feeding the material during printing, but is less ideal when we want to get as accurate of a measurement as possible. With the hot end warmed up, start by extruding a bit of material to make sure that the filament is far enough in and engaging with the extruder. Then, using either digital calipers or a ruler, pull the filament straight and mark at 70mm. While doing this, I'm not applying a ton of force to the filament, just enough to ensure that the filament is nice and straight. Since the Sharpie mark is larger than I want, I always mark beyond 70mm and then fill in up to it. I find this process much easier than trying to just mark right at 70, and it lets me know that right where the Sharpie starts is near spot on at 70mm. Once you're happy with the mark, in the printer's web interface, make sure that your hot end is at temp for your filament. Then, in the console, type G91 and hit enter. Then type G1E50F60 and hit enter to request 50mm worth of filament be extruded from the printer. F60 sets a super slow speed, so give it a little bit of time to start actually extruding. The reason for going so slow is to prevent any accidental skipped steps and make sure that our measurements are as accurate as possible. After the extrusion stops, measure from the same point you initially measured to where the mark is now on the filament. Since we marked at 70 millimeters and extruded 50, if my rotation distance was set correctly, I would have 20 millimeters left to the mark, but I measured 18 millimeters. To calculate the new rotation distance, we need three things: our current rotation distance, the actual extruded distance, and our requested extrude distance. We already know that we can get our current rotation distance from our printer.cfg file, which again for me is 21.525. The actual extrude distance is our initial mark distance of 70 minus our subsequent mark distance, which in my case was 18 millimeters. So I'll take 70 minus 18 to give me an actual extrude distance of 52. The requested extrude distance in this case is 50 millimeters. The formula for our new rotation distance is our previous rotation distance multiplied by the actual extrude distance divided by the requested extrude distance. Plugging these into a calculator, I get a new rotation distance of 22.386. Replace your previous value with the updated one, then save and restart the firmware. Klipper's documentation recommends that you repeat this process if the requested amount and the actual extruded amount has a variance greater than 2 millimeters. Mine was exactly a 2 millimeter difference, so I still decided to go ahead and run this one more time. When I reran the test and asked it to extrude that 50 millimeters again, the results were spot on. Now that we know our rotation distance is correct, we can move on to calculating flow. You may be wondering why that's necessary when we just calculated our rotation distance, so we know our printer is extruding the correct amount of filament for what's requested. The simple answer is that all filaments have a slightly different reaction or behavior when they are extruded. All thermoplastics have some level of expansion and contraction during the heating and cooling cycle. Some factors are the initial pellets used, pigments added, or the material type, which is why we need to calculate flow for each filament in order to get the best possible print quality. I'll admit that I don't typically tune the same filament type from the same manufacturer if the only difference is color. However, if I notice over or under extrusion after a print or two, I will slightly tweak my flow values. For this example, I'm using a spool of VOXELPLA's newly released PETG line of filament. Unlike for rotation distance, I want the printer set up exactly how I'll be using it when printing normally, so I need to reattach the reverse Bowden tube. I'll start by warming up the hot end and extruding a bit of this material. Jumping into OrcaSlicer, we first need to grab a rough filament profile to start with. OrcaSlicer has a ton of profiles built in, so just find the one closest to the material that you'll be calibrating. There's a generic PETG profile that I went with. If for some reason you're using an obscure filament that just doesn't have a comparable profile built in, still grab one of the existing profiles and then just edit the filament settings with the parameters given to you from the manufacturer. Next, head up to the calibration drop-down menu and under flow rate, choose pass 1. This will place a grid of 9 squares on your build plate. Other than making sure you have the correct filament chosen, don't change any settings and slice the model. Changing the color scheme to flow, we can see that a range of values will be applied to these test pieces. Each one contains a number that represents the flow rate modifier added or subtracted for that square. Once sliced, send the file off to be printed. For this test, having your Z offset dialed in correctly so that you have a very solid first layer is going to be really important. Having it too far or too close can skew the results, so make sure that you spend some time dialing that in before running this test. Once complete, take a look at the squares on your build plate. Due to the large range of values on this first test, it should be pretty easy to identify the ones that are heavily over or under extruded. Find the two that look the best. For me, this was 0 and 5, and go with the larger of the two numbers. The formula to calculate your updated flow ratio is your current flow ratio multiplied by 100 plus the modifier you chose divided by 100. The current flow ratio can be found by clicking the little edit icon next to your material in the left toolbar. For me, this is 0.95. Taking 100 plus the modifier of 5 that I chose gives me 105, so I multiplied that by 0.95 and divided it by 100 to get my new flow ratio of 0.9975. Type your new flow ratio in and save the filament profile. You'll need to name it something other than the default name, so I went with VOXELPLA PETG. Now we're going to do the same thing again, but we'll choose pass 2 from the flow rate calibration menu. This test generates 10 squares ranging from 0 to -9, giving us much smaller increments than our first test. Just like before, slice up the file, making sure you're using the updated filament profile you just saved, and send it off to be printed. This time when looking at the squares, you want to go with the one that looks best, since this will be the final value used for your filament profile. What's actually best out of these options might be a little bit subjective. I like to go based off of how the top layer looks, but I also like to go based off how the top layer feels. I want it as buttery smooth as possible with no gaps or ridges. I decided that -2 looked the best. Using the same formula as before, take your current flow ratio and multiply it by 100 and your modifier. Since I went with -2, I multiplied my flow ratio by 98 and divided that by 100 to get my final flow ratio. Add this to your filament profile, overwriting the current value, and make sure to save. Congratulations, you have successfully dialed in your filament's flow. This may seem a bit tedious at first, but I promise it's really not that bad, and now that we know our rotation distance is correct, all we have to do for any new filament is run the first pass and the second pass, and we will be good to go. I followed this up with running a pressure advance test for the VOXELPLA PETG, and then ran a decent sized print with a flat top layer so that we can see how it all looked. The top layer is super smooth, and I am really happy with the current state of this profile. I hope that you enjoyed this video and that your filament's flow is now dialed in, or at least you have a much better understanding of the process to do so. In a future video, we'll cover temperature and retraction tests. Let me know in the comments down below if you try out this method in OrcaSlicer and how it works out for you. Don't forget to like and subscribe for more great videos. We make a video every single week, so there's always fresh content coming your way. And if you do want to support the channel further, I will have links down below in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys.